Hello there, welcome to GCSE Physics. We're still on thermal properties and temperature. In our previous lesson, we talked about melting and boiling. Now we got to see that melting and boiling require energy. And then the heat energy that is absorbed before melting and boiling can take place at the same temperature is what we call latent heat. For a substance to change to a liquid from the solid state, we will need latent heat of fusion. From the liquid state to the gaseous state, we will need latent heat of vaporization. Today, we're going to see how we can measure the latent heat of fusion of ice. Now, in the setup below, a 100 watts heater is switched on for 300 seconds. So let me write this here. Power is equal to 100 watts. Time is equal to 300 seconds. Okay. By weighing the water collected in the beaker, it is found that 0.10 kilograms of ice has melted. So the amount of ice in here that melted was 0.10 kilograms. So that will be mass. Yeah, 0.10 or 0.1. It says the value of latent heat of fusion can be calculated by. Now, power is equal to energy transferred over time. Please don't forget our power equation. Power is equal to energy over time taken. But the same energy transferred is equal to mass times latent heat. This formula was seen in our previous lesson. Energy transferred is equal to mass times latent heat. So power times time, when we make energy transferred the subject in this equation, we are going to multiply both sides by time taken. So power times time taken is equal to energy transferred, which is also equal to mass times length. So we can do away with our energy transferred here and then equate these two directly. So P times T is equal to M for mass times L for latent heat. Now we want to make latent heat the subject, so we're going to divide both sides by M. And that will mean we are going to end up with L is equal to power times time divided by mass. What is power? Power is 100. What is time? Time is 300. So when we multiply these two, we are going to get 30,000. Divided by what? 0.1. Okay, divided by 0.1. And what is this equal to? 30,000 divided by 0.1 is equal to 300. 1, 2, 3. 300,000 joules per kilogram. So in this experiment, we are going to have our answer to be 300 joules per kilogram. But when you look at the specific latent heat of fusion of ice, it is around 330 joules per kilogram. Now remember, some of the energy could have been lost to the surroundings. That is why this answer will differ from the ideal answer. But this is the way you can calculate, or you can find the specific latent heat of fusion of a substance in the lab.